Alright, grade 8s, this week we're going to look at using distributive property and how it applies when we have it when we're doing linear equations. So our goal this week is to successfully use distributive property and apply it when solving a linear equation. For this week, I want you to follow along week 8 lesson 1 video, and for any extra practice, you can refer to Math Workbook 6.4. Okay, so first of all, what is distributive property? Distributive property states that A brackets B plus C is equal to A times B plus A times C. Okay, so what does this mean when we have numbers? Okay, so to make this look simpler, I added numbers. So in place of A is 2, in place of B and C are 3 and 4. So when we have a number in front of brackets, distributive property states that we actually multiply that number in front of the bracket to each of the number in the brackets. So it becomes 2 times 3 plus, because there's the plus right there, and then 2 times 4. Okay, so we distributed the 2 to each of the terms in the brackets. So what did we do here? We distributed the 2 to each term inside the brackets. Alright, so it works the same if you have variables in the equation. So when you have a question like expand the following, we're going to expand this out by distributing the 2 to every term in the bracket. So we have 2 times x, which becomes 2x, plus 2 times 3, which becomes 6. Okay, we expanded this equation, getting rid of the brackets, and distributed the 2. Next, it works the same if you have a subtraction in the brackets. We're just going to distribute the 5 to each of the terms. So we have 5 times 4, which is 20. Keep the minus, and we have 5 times x, which gives us 5x. So we expanded this again and got 20 minus 5x. Alright, so what happens then if we have brackets and linear equations? So last week and the week before, we looked at how linear equations and how we had x's in the equations and we had to isolate for the variable. Okay, so in this case, we can also use distributive property to help us solve this. Okay, so using distributive property, on our left side, we have 2 brackets x plus 3 is equal to 16. On the left side, we're going to distribute the 2. Okay, because the 2 only applies to the terms in the brackets, we're not going to multiply it to 16. Okay, so we have 2x plus 6 is equal to 16. Now it's in a form that we're used to. We saw this form last week and the week before, right? And we just solve using the same steps. Okay, we're going to isolate for x by taking away the 6 on both sides. 2x is equal to 10. And we're going to divide it by 2 divided by 2 on both sides. X is equal to 5. I'm not done here because I need to verify my solution. So go back to my original equation, which is 2x plus 3 is equal to 16. And we need to solve to see if it's true when x is 5. So in place of x, I'm going to put in 5 is equal to 16. So when you have this, don't feel like you're solving an equation left to right. You're actually doing left side and the right side. So solve the left side. When we solve equations like this, solve expressions like this, we're gonna follow BEDMAS rule and apply brackets first. So we have 5 plus 3 is 8, and then we're gonna multiply 2 times 8 is 16. 16 is what I have on the left side, and 16 is what I have on the right side. So they're equal, so that means my answer is correct. Okay. Alright. We're going to go over one other way to solve when there is a number in front of the brackets. Okay. I want you to see that. Remember how if we have 2x, it's the same thing as 2 times x. Okay. So that's the same thing as if we have 2x plus 3 in brackets like this. It's the same thing as 2 multiplied by x plus 3. Okay, how do we get rid of the 2? If it's getting multiplied to this term, okay, we're going to divide it out to get rid of it. So if we have 2x plus 3 is equal to 16, if I divide the 2 on both sides, I end up canceling the number in front of the brackets. Okay, whatever I do to the left side, I do to the right side. That's why I'm dividing by 2 on the right side. On the left side, I have x plus 3 left, and on the right, I have 8. Take away 3, take away 3, x is equal to 5. And that is the same answer I got using distributive property. Okay, so you can use either methods here. Let's try a question using both methods. Let's try one where we are using our distributive method first. Okay, so we have 5x minus 6 is equal to 20. We're going to distribute the 5 to everything in the bracket. So 5 times x is 5x. And then keep the minus. 5 times 6 is 30. Okay, and that's equal to 20. And I just do my Sam and Deb. So add and subtract first. And then I'm going to divide or multiply. X is equal to 10. And that's the answer I got. I'm not done because I need to verify my solution. So I go 5. In place of x, I'm going to put in 10 is equal to 20. 5 times 4 gives me 20. 20 is equal to 20, so this works. Okay. We're going to try the other method of dividing out the number before anything. So we're going to divide the 5 first on both sides. Okay, get rid of that, and x minus 6 is equal to 4. Add 6 on both sides, x is equal to 10. I get the same answer here. Okay, you can use any method you like, whichever one works best for you. Okay. All right, we're gonna have word problems with this topic too, so let's look at the word problem here. So Mia has a fence around her new tree in the shape of an equilateral triangle. So that's an important information here. This fence is the shape of an equilateral triangle. She wants to increase the length of each side by 7 centimeters. So she wants to increase it by 7. So we want to add 7 to all the sides. The perimeter of our new fence will be 183. So 183 centimeters is our new perimeter. Write an equation to model the situation and then determine the length of each side of the old fence, okay? All right, so we can draw a equilateral triangle. Remember, equilateral triangles, all 3 sides are the same. What we don't know in this question is length of each side of the old fence. So if this is our old fence, let's say each length was x, because that's what we don't know. So we're going to say x is equal to length of each side of the old fence. Okay. Right, what else do we know? She wants to increase each side by 7 centimeters, and when she does that, the perimeter becomes 183. Perimeter of an equilateral triangle becomes 3 times each side. Okay, actually let's write 3 times each side, because we have 3 of the same things, right? Okay, but the each side for her new perimeter isn't just x. She wants to add 7 to each side, so we're going to add 7, add 7, add 7. So her new fence, on her new fence, each side is equivalent to x plus 7. So to get the perimeter of her new fence, perimeter of new, okay, we're going to go 3 times x plus 7. And the question tells us that the perimeter of the new fence is 183. So it is 183 is equal to 3 times x plus 7. Okay, so here's the equation that we're going to work with. This is the equation that models the situation right now. And we just have to solve for x to get the length of the side of the old fence. Okay, I'm going to use distributive property here to solve this equation. Okay. So I'm going to distribute the 3 to both sides. I'm just going to move the equation here. So I have 183. 183 is equal to 3x plus 3 times 7 gives me 21. Okay, don't get confused just because your variable's on the right. It's the same steps. I want to isolate for my x, and that's what I'm going to do. I'm going to get rid of the 21 by taking away 21 on both sides. Then I'm left with 3x on the right side. On the left side, I have 162. And I'm going to divide it by 3 on both sides. when I do that, I have x on the right side, and on my left side I have 162 divided by 3, which gives me 54. Okay, so x is equal to 54. What does this mean? We said that x represents the length of each side of the old fence. Okay, so that's the answer to our question. Our unit here was centimeters, so our final answer is 54 centimeters. Okay, so be careful when you're setting up the equation for the word problem part, and then when you have the correct equation, the solving method is the same. Okay, so the main ideas this week, okay, when you have brackets, expand using distributive property, or divide the number in front of the brackets on both sides and get rid of it. Okay, and then it's the same. Isolate the variable, do opposite operations on both sides, and verify your solution. All right, so we went over 2 methods of dealing with brackets when you see them in equations. I want you to practice using week 8 task 1. But this is a very important concept for next year. So if you have time, okay, make sure you do the extra practice that are in your math workbook 6.5. If you don't have your workbooks, we will post it on D2L as a PDF format. See you guys next week.